Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at a new topic now that is introduced in grade 12, called now calculus, right? Yes. So now we have different chapters in calculus. So the first one that I have to introduce you to, it is now how to understand what we refer to when we talk about the limit, okay? So now let's have an expression that says to us limit as x approaches c of t of x, like that, okay? So what we're gonna do here, we're gonna say, okay, now we want to find the limit of this function as what? As x now approaches what? Approaches c. Okay. Now we want to find the limit of a function as x approaches what? C. So what do? We say, okay, in place of x, we substitute what? C. So this is going to give us what? T of c. Okay. This is what we mean the of. Okay. Now, limit now says to us it happens now to a function f of x or particular function when x tends to approach a specific value. Okay, but now let's not go into depth about the theory. For now, you don't need the theory. You need only how to apply. Okay, yes. Now, let's have let me see. Okay, let's have examples. Okay, examples. So on the examples, let's say we have just one limit as x approaches 2 of what? Of x squared plus 3x. Okay. So how can I evaluate this limit thereof? Okay. I'm going to say equal sign. Remember, I'm trying to evaluate my limit as x approaches what? 2. So what I'm going to do, I'm going to, in place of x, I'm going to substitute what? 2. Okay. And the minute I substitute this limit or x is equal to 2 on this function thereof, I no longer write my what? My limit. It means I'm going to say this is 2 squared plus 3 into 2. Then when I do my mathematical gymnastics there, I get something like 10. Okay. Yes. This it is equal to 10. Now, let's have another one. Let's have another one. Limit as x approaches 1 of x minus 2 divided by x plus 2. Okay. So how can I do this? What you have to check first is that, is it possible for me now to substitute 1 in the denominator and it does not give us 0? Ne? What you don't want to find is you having something divided by 0. Remember, this is undefined, so you want to make sure that you cannot divide by 0. So in this case, it does not breach any rules, so we can directly substitute and say now 1 minus 2 divided by 1 plus 2. This gives us something like -1 divided by 3. Now, the last example, this is interesting. Okay. 3. Okay. Let's have this one. Limit as x approaches 3 of x squared minus x minus 6 all divided by what? By x minus 3. Let's have that. Okay, I want to believe you are attempting it then. So now let's see. If I substitute x as 3, do you see here I'm going to have what? I'm going to have 3 minus 3 at the denominator, and I do not want what? To divide by what? By 0. So I cannot directly substitute in this case. What I might do is say, okay, limit as x approaches 3. I have to make sure, how can I remove this x minus 3? Okay, I have to ask myself, how can I remove this x minus 3? Because it is the one that disturbs me from substituting x as equal to what? To 3. Because when you punch this on your calculator, it's going to give you what? Undefined error. Okay. So what we're gonna do, we're gonna say, okay, let's try to simplify the numerator. It's gonna be x minus 3 and x plus 2 divided by x minus 3. Can you see now? Okay, this one cancels off with this one. Then we have what? Limit as x approaches 3 of what? Of x plus 2. Then I'm in a position of substituting then 3 plus 2. Then it gives me how much? 5. Okay. Then okay, let's do this one and see if you are understanding that one as approaches 2. Try to pause the video and do this on your own, okay? Try to pause the video and do this on your own. Okay, so now let's attack it. Can I substitute 2 directly here? Can I directly substitute 2 here? Yes, I can. Why? Because now 2 multiplied by 2, it is 4. 4 plus 4. Can you see that? It does not breach any rules, okay? So I do not want to divide by 0. 0, it is acceptable at the numerator, it's fine, but you do not want 0 at the denominator, okay? So we're going to say this is equal to what? 2 squared minus 4 divided by 2 into 2 plus 4, which is 0 divided by anything, it is 0. Okay, yes. So now I want us to move into something interesting now, that we call a gradient of a what? Of a function. Okay, gradient of a function. Now suppose you have a function given by the name of f of x, right? Let's now be in a position of finding what? The gradient. Okay, gradient of a function. This is where interesting stuff starts. Gradient of a function. Now, how do I find the gradient? Remember, for a gradient, I need what? I say m, it is equal to y2 minus y1 divided by what? By x2 minus x1, right? So here, this is going to be my x1, my x2. Now, what is the corresponding y value of this x2? Sorry. What is the corresponding y value for this one? Again, we do not know it, but we know, remember, y, it is f of x, it is similar, it is the same as y, right? So we can say, instead of stressing ourselves, we can say, okay, this will be the same f as f of what? When x, it is how much in this case? Can you see? When x, it is x plus h, okay? So this is going to be what? X plus h, okay? Minus what? F of x, okay? F of x. We wanted this y value here, okay? Then we want this y value. Now we said the y value of this one, it is what? It is f of x plus h. Well, on this one is going to be f of x, like that only, okay? Then divided by x plus h minus x. Do you agree with me? When I simplify this, I get f of x plus h minus f of x. all divided by what? All divided by h, right? This is the gradient. But now I want you to see something. The gradient that we just found right now, it is the gradient of a secant line. It is not necessarily a straight line. Like, can you see? It is between these 2 points. It is the gradient of a secant line. It is not necessarily straight. Okay. If I were to draw that neatly, if I were to zoom out in this portion there, if I were to zoom out here, it is something like this. Something like that. Can you see now? This is a secant line, but now we want this line now to have a gradient of a tangent now. Okay, we want to have a gradient of a tangent now. Okay. So now, do you agree with me that the distance here it is h? So now, how can we now try to make this now gradient of ours to be exactly the gradient of a tangent? Now that's when we introduce something that we call limit. So you're gonna say m, it is what? It is f prime x. Okay. This refers to the what? To the gradient of a function. Okay. This is what we call the gradient of a function. Okay. It is equal to limit as h approaches 0. Okay. As h approaches 0 of what? Of f of x plus h minus f of x, all divided by what? By h. So now this is the formula that we call the first principle. Okay. This is the formula that we're going to be using more often. Okay. First principle. Okay. Yes. So now let's now be in a position of knowing how to do what? How to use the derivative of a function. Okay, how to use the derivative of a function. Now, I'm gonna note down the formula so that you do not forget it. Okay, let me take this formula with me here. Okay. Every time when they say first principle, what? Now, this is where you have to come there off. Okay. Yes. Now, I'm gonna teach you the tips now of finding the derivative using the first principle using this formula. Okay. Now let's have an example. Now let's say to us they say find f prime of x from first principle. Okay. If now you are given f of x as how much? As 2x squared. Now let's try to solve that. The first step that I'm gonna want you to do, it is now you have f of x here, it is right. Remember your formula has what? Has f of x as well as f of x plus h, right? What I want you to do, I want you to say, okay, I already have f of x. So how can I find f of x plus h? Now what you do here, it is when you see this function where you see x actually on f of x, you add what? H. What do I mean? I mean, remember this is the original formula of f of x, right? Let me rewrite it actually. Number 2, I want f of x plus h. It is 2. Where I see x, I'll substitute what? X plus h, then I square. Can you see that? When I see x, I open a bracket and add what? H. And then I square that. This will act now as a new x, but now it is now with it is added with h thereof. Then I need to simplify this a little bit further. This is going to be 2 multiplied by, when you simplify this, you get x squared plus 2xh plus h squared, which it is equal to now 2x squared plus 4xh plus 2h squared. Now, another tip again. When you find your derivative or your f prime x, if you're given f of x as this one, can you see now our power here, our exponent here, it is 2, right? Now that our exponent it is 2, it means when I'm going to come here into this formula, when I substitute, it means something that has x squared should vanish. Okay, you'll understand what I mean by that. Another thing I like to do before going to the formula, I like to say, okay, let me express this so that when I go to the formula, I substitute further. F of x plus h minus f of x. Where do I take this? I take this from the formula. Okay, you can directly substitute, it's fine, but I want you to avoid mistakes. Okay, what is f of x plus h? F of x plus h, it is 2x squared plus 4xh plus 2h squared minus what? 2x squared. When I simplify this, can you see now this one will cancel? This one will cancel that, okay? Then we'll be left with 4xh plus 2h squared. Remember what I said? I said when you substitute into this formula, f of x plus h minus f of x, something that has x squared, I said x squared, something that has x squared should not appear when you after finding the difference here. Can you see now on this difference we do not have x squared? Okay, yes. So now we are in a position of going to a formula and saying, okay, f prime of x, it is equal to limit as h approaches 0 of what? Of f of x plus h minus f of x, all divided by h. Okay, now the question is, can we directly substitute 0 here? The answer is no. Why? Because you cannot divide by 0. So what should we do? Okay, remember you have f of x plus h minus f of x. Okay, it is how much? It is this one. Okay, what other people will say, okay, after finding f of x plus h, they come into this formula and then they start substituting there. That's fine. Okay, that's fine. Another important thing, as you move on, before, okay, you're gonna continue with limit as h approaches 0 until I'll show you which step. What is this? Remember this, we have as what? As that. Sorry, we have as this one here, right? So here I'm gonna have what? Can you see now it's easier when I come to the formula and just substitute everything like this, instead of coming to the formula and now manipulating everything into the formula, right? So then I'm still continuing with limit, okay? Remember my goal, it is to remove this h at the denominator. That is my goal, okay? Can I do something? Yes, I can take out h as highest common factor. Then it's gonna be what? I'm gonna be left with 4x plus 2h divided by h. Now, can you see now this h and this h, they cancel off, yes. Then I'm left with what? With limit as h approaches 0 of what? Can you see I'm only left with 4x plus 2h. Am I in a position of substituting? Can I substitute h as 0 now? Yes, now I can substitute what? H as 0, because I'm not violating any rules, okay? I'm not dividing by 0. So when you substitute, remember I said when you substitute, you do what? You just say 4x plus 2 into 0. When you substitute, you no longer continue with limit, okay? That is very important. Then your answer, it is how much? 4x there, okay? Yes. Let's have another example. Let's have another example. Let's have another example. Example 2. Let us have x squared minus, okay, find f prime x. They're gonna tell you from first principle, because why? As we go on, we'll be now knowing rules, okay? Find f prime x from first derivative, first principle. Principle, if f of x, it is given to you as x squared minus 2, okay? So how do we move about this one? Remember the first step, let me just write f of x so that I can see it is what? X squared minus x. Okay, you can pause the video and try this one on your own. Okay, second step, I want what? F of x plus h. Remember, you do not need to cram the formula for limit as this one. You do not need to cram this formula because now you are giving this formula on your formula sheet, okay? You do not need to cram this formula you are given. Okay, what is f of x plus h? Remember, what did we say? We said when you see x, we're going to open a bracket and put x plus h, meaning x plus h, then we square everything. So this is minus 2, minus 2. Okay, then we get what? We get x squared plus 2xh plus h squared minus 2. Okay, I repeat, everything that's here on the formula, when you substitute into here, they should not appear. They should just disappear. Okay? Yes. Okay. Now let's see if that's the truth. Then let's find f of x plus h. If the way I'm doing it, it is trickier for you, you can follow the way that your teacher does it. Okay. Either way, they are both correct. It is equal to, what is f of x plus h? This one, the one I'm doing it is for easier mathematics, okay? It's going to be x squared plus 2xh plus h squared minus 2 minus. Can you see now I have two terms? Remember that on this one, when I substituted, I only substituted here minus, I only said minus 2x because it was a mono, just one term, right? But here we have two terms, so you do what? You open a bracket and say what? X squared minus 2. Let's simplify this. This is going to be x squared plus 2xh plus h squared minus 2 minus x squared, negative by negative, it is plus 2. Then can you see now x squared and x squared cancel off? Negative 2 and plus 2 cancel off. Can you see what I meant when I said x squared minus 2? It won't appear, it will vanish. Similarly to here, everything that we had on f of x, here, it vanished here on the f of x plus h minus f of x. Can you see? Yes. So that's another thing you have to, I want you to take note of so that you can spot mistakes, okay? Then here we have what? 2xh plus h squared. Then I'm in a position of saying, okay, f prime x, it is equal to limit as h approaches 0 of what? Remember, do not forget to write the formula. It is very important. Okay? Divided by h. Now remember I continue with limit until the final step. What is f of x plus h minus f of x? This, I have simplified it already. Can you see how nice that is? Divide by h. Now remember, the goal is to remove this h. How can I do that? I can do that by saying, okay, just remove h. I'm left with 2x plus h divided by h. Now h and h cancel off. I still continue with limit, remember? Limit as h approaches 0 of what? I'm left with 2x plus h. Am I in a position of substituting now h as 0? Yes, I can do that, okay? I can do that. Therefore, it is equal to, so remember, when you substitute, you no longer write limit plus 0, which is just basically 2x, okay? What if I told you that I can directly find an answer from f of x? and say now the answer it is 2x. Now have your own here. Have your own here. 2 minus x squared. Okay. Find the first principle. Find f prime x using the first principle and get this answer. The answer that you're supposed to get it is, okay, the answer that you're supposed to get it is f prime of x, it is equal to negative 2x. This is the answer that you're supposed to get. Just do that, okay? Just do that and then, yeah. Okay, let's have another one example. Then we continue to other things. Let's have the last example under the first principle. This one, it is it is normally tricky on many students. Okay, find f prime x from first principle. If f of x it is equal to 1 divided by x. How nice. First step, remember I just write what is f of x, okay? 1 divided by x. Then number 2, I write f of x plus h. What is that? Remember where I see x, I'll just add h like that, okay? Then the third step, I want f of x plus h minus f of x. It's going to be what? 1 divided by x plus h. Okay, let me do it like this. What's happening? 1 divided by x plus h minus what? 1 divided by x. This is f of x plus h minusing what? F of x. Like that, okay? Now, the lowest common multiple here, LCD is going to be x into x plus h. Like the LCD here is going to be this and this, okay? Both of them, okay? Therefore, now that I know the LCD, what I'd recommend you to do is just multiply this to the other side. It's going to be what? It's going to be x minus of this one, right? Then multiply all of this to the other side like that. You're going to have 1 multiplied by x plus h, which is the same as x plus h, okay? Put a bracket. It's very important to put a bracket. Very important. If you do not put a bracket like that, you're going to make a mistake. Minus 1 into x plus h. Okay, this is me just multiplying. Then remember, divided by the LCD, which is x into x plus h. Can I simplify any further? Yes, I can simplify any further and say, okay, this is the same as, can you see that x minus x, I can remove this one. It's going to be x minus x, right? Which is 0. Then negative multiplied by positive. This one is going to be negative what? Negative h divided by, I can simplify the bottom as x squared plus xh. Okay, this is my f of x plus h minus f of x. Okay, then I come where? I come into the formula and say, sorry. Remember the formula says f prime x, it is equal to limit as h approaches 0 of what? Of f of x plus h minus f of x, all divided by what? All divided by h. Then I'm in a position of substituting. What is f of x plus h minus f of x? Remember, it is this one. Do not write this under one line, okay? Please do not say negative h, like, no. I recommend you to say it is limit. Remember, you forgot limit. From this step going down, you forfeit marks. Okay, everything is going to be wrong. So f of x plus h minus f of x, it is negative h divided by x squared plus xh. Then I'd recommend you to use this division, divide by h, like that. Okay, this one, it is just here. Okay, This is just here. Okay. Now remember, what did we learn? We learned what tip and times. Okay. What did we learn? We learned tip and times. Remember, we want to remove all the H's. So remember, what does tip and times say? Tip and times say when I change this sign into multiplication, I take the reciprocal. Remember, this is over 1, right? This will be 1 divided by H, like that. Okay. Then now I'll say limit as H approaches 0 of. Can you see now this H will cancel off this H? Yes, I'll be left with what? This is not 0, it is -1. Divide by what? By x squared plus xh. Can I substitute h as 0? You have to always check. When I substitute h as 0, this will become 0 again. But this one will just be x squared, so it means I can. As long as the denominator, all of it, does not become 0, I'm fine. Then when I substitute, it becomes -1 divided by x squared plus x into 0. Remember, when I substitute, I do not care about the limit anymore. This will give me -1 divided by x squared. Okay, yes. I want to believe it is clear now from the first principle thereof. Okay, yes. Now, let's move on to what we call differentiation rules. Okay, let me insert a page above, insert a page above, insert a page above. Let me see. Good, good. Now, let's come to differentiation rules. Okay, or rules of differentiation. Now, these are very important, these rules, because now most of the time you're going to be focusing on them. Okay. Okay. Another part, you're going to have on your question paper, you're going to have only one question that requires always this one. Do not say, I'll just see it. It is always there. Make sure you know first principle, 5 marks guaranteed. Easy 5 marks. Okay. These are easy 5 marks. Rules of differentiation. Okay. Now, the first one is that, okay. Mm, okay. The first one that we have, we say now the derivative of a constant is 0. Let me write it here. The derivative of a constant, it is 0. What do you mean? Can you see I'm saying derive C? This is how we call this. Derive C with respect to what? To x. Can I see x here? No. If there is no x here, it means now this will become 0. Okay? I say derive C with respect to x. What do I mean? This is the same as saying, okay, let's have an example. When I say now, derive 5, okay? Derive 5 with respect to x. Does it have x here? The 5 does not have x, right? So when you derive a constant, every time when you derive a constant, it is always 0. Remember, even pi or dx, or even if they say dt of pi, this is how much. Can I see t here next to pi? No, therefore pi is a constant. I put 0. Okay, everything will make sense. For now, I know it's going to be a little bit confusing. The second one, it is now the power rule. Power rule. This one, you're going to be using it most of the time. These two, basically. Okay. Now, let's say now we have dx x to the power of n. Now, can you see I can derive x to the power of n with respect to x. Why? Because I have x now. Therefore, if I have x, this is not equal to 0. This one is equal to 0 because it was just a constant number. Okay? Constant number. Then here, if I have x like that, I'm deriving with respect to it, right? So I'm going to say this is going to be equal to, check. The first thing that I do, I multiply this n into the coefficient. I get n. Okay? Therefore, I write this one as it is. I write this one as it is. All right. Mm. Yeah. Yes. Okay, sure. Okay. I remember the first thing that I did, I multiplied by the n into the coefficient. Again, I'm not removing it, I'm just multiplying by it. Then I have x to the power of n. Then I do what? I subtract 1. This is how we're going to do this. What do I mean by that? Let's have an example. Let's have an example. Let's say they say derive with respect to x, what? X squared. How can I do this? Remember the first thing, you multiply this one. Actually, you drop these two, right? It's going to be 2. Then the x squared, you leave it as it is, but you have to do what? You have to subtract 1. Then you get something like 2x to the power of 1, which is basically 2x. Okay, let's have another example. Let's have another example. Dx of 2x cubed. What do the rules say? The rules say now to us, we first multiply by that one. Okay? Then it becomes how much? Can you see when you multiply by that one, it is 3 multiplied by 2, it becomes 6. Then we have what? X cubed. Then we do what? We subtract 1. This gives us 6x cubed. Like that. How easy. Very nice, nah? Very nice. Very nice. Okay? Now, there are some things that we should respect, nah? Okay? Rules. The first rule says now to us, the first rule, we do not want what we differentiate with respect to be under a radical. Okay? When it is like this, you have to change it into x to the power of half. Okay? Or if you are having square root of square root of or cube root of 2x, what you have to change this, you have to say 2x all raised to the power of 1 divided by 3. Just apply rules of exponents. We do not want what we differentiate with respect to be where in the under the square root. Okay, yes. The second one says what I differentiate with respect to should not be at the denominator. What I derive with respect to should not be at the denominator, meaning I have to change this one into what? 1 multiplied by x to the power of -1. Remember when you take this at the top to the top, you introduce -1. Remember the rules say 1 divided by 8 is the same as a to the power of -1. Okay? If I have 1 divided by a squared, it is what? A to the power of -2. Now, the question is, what if I have 1 divided by a? Remember, if I'm differentiating, okay, let me just put x. If I'm differentiating with respect to x, I only want x. I do not want x at the denominator. So I just take x, only x. I say 1 divided by 2. Can you see I let 2 be at the denominator because I do not care. Then I say x to the power of -1. This is the same as that. Okay? Yes. Or let's say I have 3 divided by 4 x squared. This I'll change to what? Remember 3 divided by 4, I do not care about it. You can just put it here as -2, like that. Okay? Okay, yes. Now, there are many ways to write the derivative, okay? Ways to write the derivative. Ways to write the derivative. Derivative of y is equal to f of x. What do we mean by that? Now we have many ways. They can say to you, the first one, they can say to you, when you write the derivative, this is f prime of x. This is when you are given what? F of x. Okay? Okay? Actually, let me say, when you differentiate f of x, you get f prime of x. Yes. I'm coming. Hmm? Mhm. What? Mhm. Okay, then we say f of x, it is denoted as f prime x. Then if we are having y, you're gonna denote it as y prime. Okay, y prime like that. This one is called f prime x, or the derivative of x, right, with respect to x. Then the third one, we just have dy. Okay, this one can be written as y prime or dy dx. Okay. Yes. Then the third one we can say now dx, like this. Okay. So these are the notations that we're gonna be using in the next video, when we now do more calculations now based on the derivative. Okay. So yes. Thank you. Mm.